In the first lab session, we were introduced with both the structural and behavioral representation in Verilog. Now to recap, the structural representation, the circuit of this function is described using the gate instances of the inbuilt gate library, whereas in behavioral representation, the circuit is described in terms of the Verilog operators. So as I discussed before, we will be using the structural Verilog code for today's lab, that is the code snippet on the left. In this slide, we will see a rough flow diagram of the automated layout generation process. At first, at the design specification stage, the circuit description is inserted into the software in the form of a text file or a Verilog file. Next, the circuit netlist is extracted from the input using logic synthesis. After that, logic gates and the intergate connections are mapped onto the hardware using the gate library and technology-dependent design group. So this is a stage that the automatic layout generation process takes place. The compiler takes care of certain tasks at this stage, such as floor planning, placement, and routing. The generated layout can be verified using timing diagrams to check whether it is functionally correct or not. In the remaining slides, we will investigate how we can perform the automatic layout generation task using the MicroWin2 software through two example circuits. First circuit takes four inputs ABCD and has one output Y with the input-output relation described by this equation. Here we have the structural Verilog code for the circuit, and this is how the circuit schematic looks like. Now let's move on to the MicroWin software and figure out how we can perform the layout generation task.